Hi, everyone, and thank you for joining us. My name is Yuri Diorgis, Principal PM Manager within Microsoft Defender for Cloud team. I'm excited to have you join our session, Implementing Synapse Strategy to Embed Security from Cloud to Cloud. In this session, we are going to first recap Microsoft's point of view in what is Cloud Native Application Protection Platform, or CNAPP. Then we'll make the CNAPP principles relevant to cybersecurity professionals by sharing some practical implementations and strategies for Defender for Cloud. So first, what is Cloud Native Application Protection Platform, or CNAPP? If you do some research, you will typically find researchers are using more terms to explain this term. Well, according to them, a CNAPP should include a list of tools like infrastructure as code scanning, cloud workload protection, and cloud secure posture management. And let's pause for a second, as that's a mouthful. What does all that translate into customer benefits? At Microsoft, we believe CNAPP should be more than just compilation of individual functionalities. It should combine previous silo security features into an end-to-end solution for cloud security, and doing so facilitate collaboration between secure stakeholders. To illustrate that, let's look at some typical challenges faced by different teams in securing their cloud environment. First, developer teams don't have security integrated into DevOps pipeline and built in bidirectional communication tools with security administrators. And then for security administrators, they don't have centralized visibility into their cloud configurations, nor the prioritization and governance tools to operationalize efficient remediation. Finally, for threat responders, the SOC team, they must manually catch threats like malware and integrate threat protection into DevOps and security administration workloads. If you pay attention, on top of security challenges within their own roles, security stakeholders also need ways to better work with each other. In understanding the need, here is Microsoft CNAPP offering, Microsoft Defender for Cloud. We want to help our customers to start secure from code itself and then stay secure with posture management and threat protection in runtime. This means we not only take signals from DevOps security, posture management, all the way in runtime alerts, but also surface relevant information to customers in a way that is easy to digest and is actionable. In other words, Microsoft CNAPP is more than a compilation of tools, but also a platform to break silos and efficient collaboration in secure remediation. From here, I'll give it to Lior, Senior Product Manager within Microsoft Defender for Cloud team, to talk about cloud secure posture management. Lior, the floor is yours.
Thank you, Yuri. As Yuri discussed, cloud-native application protection platforms need to facilitate better collaboration between security stakeholders. In addition, they need to provide tools and processes to help security professionals work more efficiently with context. Today, I would like to share with you how CSPM capabilities within Defender for Cloud can help security admin to reduce recommendation fatigue, conduct efficient risk prioritization and risk hunting with context in multi-cloud environments. But before that, let's recap some of the main customer pain points we have seen. Today's security admin are faced with three main complex scenarios when working to reduce risk across the environment. First, how can security admin gain visibility of their multi-cloud environments to find the most important potential risks? Second, how can security admins proactively explore and hunt risk in their cloud environment to prevent future breaches? Lastly, how can security admins can be informed with operational expectation like due date and accountability so they can remediate security recommendation with an ease of mind? Now, let's look how Defender for Cloud can help in these scenarios.
As a security admin, I would like to monitor the overall security status in my environment and identify potential risks that attackers can use to breach the environment. Using the attack path analysis capabilities, Defender for Cloud scans the graph and detects exploitable paths. It helps you mitigate them and prevent future breaches. As part of my day-to-day job, I review security recommendations generated by Defender for Cloud. Here, on Security Recommendations page, I see almost 1,000 resources that have security issues. However, only a small portion of them is related to attack paths that attackers can exploit. I would like to focus on the most important ones and take action to resolve them. Let's explore and review a list of attack paths found in my environment. Defender for Cloud identified several attack paths in my environment. For Azure and AWS virtual machines, Defender for Cloud found vulnerable and exposed instances allowing lateral movement. For Kubernetes containers, Defender for Cloud found running and vulnerable images that allowing remote code execution. And for data services, Defender for Cloud found storages that has sensitive data and exploitable SQL servers. Now, let's examine two attack paths to understand how it works. Let's examine the first attack path. In this example, Defender for Cloud identifies virtual machines that has high severity vulnerabilities that allowing remote code execution. This machine is also directly exposed from the internet and also has read permissions to a key vault. This serves a combination of issues allowing attackers to exploit the vulnerability and move laterally in my environment. As a result, Defender for Cloud suggesting resolving relevant vulnerabilities to break the attack path and reduce the risk. I would like to focus on the findings that I need to resolve to make sure this is no issue anymore. I can see two findings and the associated CVEs. To make sure someone is remediate the security recommendation and reduce risk, I will use the integrated governance capabilities. I can assign an owner to be notified on the issue, select a specific time frame, and click on Save. The owner will be notified to resolve the issue and to break the attack path. Now, let's examine another interesting use case. Using the integrate data-aware security posture capabilities, Defender for Cloud also able to detect attack paths relevant to sensitive data. In this example, I can see internet-exposed Azure storage accounts containing sensitive data. I can see multiple storage accounts and storage containers. Clicking on the storage containers, I can see that this storage container is allowing public access and containing sensitive data. I can see a list of files, for example, and also the insensitive information type found in those storage accounts. The same as the previous example, Defender for Cloud suggesting relevant recommendations that needs to be fixed to resolve the issue. Again, I can use the assign owner to assign someone to remediate the issue. To summarize, using attack path analysis capabilities, Defender for Cloud identify the riskiest issues in your environment and help you resolve them fast to prevent future breaches. In addition, the integrated governance capabilities allow you to set accountability and drive remediation. Now, let's focus on the second scenario. As a security admin, I would like to get visibility and explore the entire cloud state, especially in scenarios where attack paths not yet exist. I would like to proactively understand the pain points in my environment and hunt for specific use cases. For example, get all the virtual machines that are exposed to the internet and are running a specific critical vulnerability. Or get all the data services that are running with sensitive data and exposed to the internet. To do so, let's use the Cloud Security Explorer. Now, let's get back to the left menu and click on Cloud Security Explorer. The Cloud Security Explorer allows you to customize Defender for Cloud findings and run custom queries on top of the graph. You can start by building your own query from scratch or use one of the predefined templates. Let's build a query together. In this scenario, I will use one of the predefined templates, which is the virtual machines with the OpenSSL v3 vulnerabilities. I will click on Open the query to reveal the underlying query. Clicking on Search, I get a full list of virtual machines that are running with the OpenSSL vulnerability. However, I would like to narrow it down and add an insight. For example, all the virtual machines that are running with the OpenSSL vulnerability but also exposed to the internet. Clicking on Search, I get a new list of just the virtual machines that are exposed and running with the specific vulnerabilities. I can see how this machine is specifically exposed and get more information about the vulnerability. Let's use another scenario and build a query from scratch. Using the data-aware security posture capabilities, I can also hunt for specific cases for sensitive data which is exposed to the internet. Using the query builder, I will focus on data services like on storage and databases. Let's click on Done and click on Search. I get a full list of storage accounts and databases. But I would like to narrow it down to add insights like all the data services that are allowing public access and also contains sensitive information. Clicking on Search, I get a list of all the storage account and databases that are exposed to the internet and also contain sensitive data. Here I can see a storage account on Azure that has multiple files containing sensitive data like IP addresses, PII information, bank accounts, and so on and so forth. To summarize, the Cloud Security Explorer helps you query the graph for your own custom findings to meet your organizational specific needs.
From here, I will pivot to DevSecOps to allow Karen to introduce CNAPP implementation based on the Defender for DevOps capabilities.
Thanks, Lior. My name is Karen Damon. I'm a Principal Product Manager and Defender for DevOps. As we've talked about, security admins have a lot on their plate. There's some unique challenges for these admins as they shift into the DevOps context. Security and development teams are continuing to operate in silos. They don't have a shared view into DevOps security posture. What's more is security tools aren't well equipped to keep pace with developer velocity. And all of this means security admins are wasting precious time and resources, tracking down issues and delaying fix rates. We know cloud security has to be a team sport. We need to look across code to cloud and think about how can we reduce overall risk in the cloud environment. Organizations need an end-to-end security solution, helping start secure by incorporating security within an application as it's developed, and staying secure by configuring cross-cloud defense throughout the application lifecycle. In the following demo, we're going to take a look at how Defender for DevOps is unifying security of cloud apps and improving communication between developers and security admins.
Okay, starting from our DevOps security blade on the left-hand side, you can see we have GitHub and Azure DevOps environments and more to come. I've already created 2 of those connectors and auto-discovered a total of 38 repositories. And in doing so, I now have combined visibility across scan types: code, infrastructure as code, open source software, and secrets. So let me click into infrastructure as code. Here you're going to see a set of unhealthy resources where the checks were performed and didn't pass, and healthy resources, those where the checks were performed but did pass. I have a set of findings. I'm looking for something specific to blob storage. Okay, here it is. We know that blob containers should not allow anonymous access. I get a description about the issue, some more details about where to find it, all the way down to the line of code. But what happens when I want to know more details inside the developer experience? Here you can see I can deep link over the exact developer experience inside of GitHub where there's a security issue that's been created, and it gives the same details we just saw in that context played inside of MDC. Again, giving developers the tools and the context they need to do the work to remediate before this reaches production. Now let's jump back to our DevOps blade. Another problem we want to solve is around ability to better collaborate between security admins and our developers. In this case, we've created this pull request status. You have different repos where this has already been enabled and a few where it hasn't. Let me show you how easy it is to actually get this enabled. You select those repos, turn it on, save, and done. In this case, I've already enabled this on Contoso Hotels. So let's go check out this finding and see what it looks like inside the developer experience. We'll get more details about the actual credential that's been found, in this case an Azure Storage Account Access Key. And then we're going to pop over inside of ADO and show you exactly what happens when a developer checks that in. Again, we enabled inside of our security pane of glass that pull request annotation. And in doing so, when we checked in a piece of code, the developer checked in code, and they included this specific account key you can see here. They've done that in a way where they've already immediately been given Microsoft Defender for DevOps, decorated pull request with all the details about the secret and what to do to remediate. Again, never having to leave their preferred pane of glass, which is Azure DevOps. Now, lastly, let's talk about the context and prioritization. We're going to go up to our Cloud Security Explorer now. We're going to select those resources we just onboarded through the connector, the code repos. And I'm going to show you what that list looks like with no filters, looking at all the different repos we've onboarded. Not super helpful until we add some more conditions. First thing we're going to look for is publicly accessible repos. All right, this should be a shorter list, not as many. But I want to get to an even shorter list. Show me all the publicly accessible repos that contain creds in code. So what I'm going to do is add a condition around recommendations. In this case, where code repositories should have secret scanning findings resolved. We have our longer list. I'm going to hit search. And here we go. We have a much shorter list and a specific set of actions we can go tackle to remediate the highest priority issues. So with that, let's hand it over to Yuri for the cloud workload protection scenario.
Thank you, Karen. As we discussed in the beginning, cloud workload protection is the key solution to help organizations detect anomalies and enforce policies at the early stages of an active threat. And in Defender for Cloud is the only CNAPP solution that benefits from integrating insights from 65 trillion data signals to provide comprehensive multi-cloud coverage across servers, containers, database, service layer, storage, and more. The challenge of cloud-native application protection is not only having a comprehensive protection coverage as possible, but also applying the right integration to drive collaboration. SOC analysts are in the forefront of detecting and responding to threats. However, it will be unrealistic for them to catch all threats and stop them early if they don't have both breadth and depth of understanding of what's going on in their cloud environment. This is particularly true in data security. If dangerous malware can be detected as soon as they can reach the cloud, the SOC analyst will be able to stop breach at much early stages and gain better control. In the following demo, we will first give you an overview of what's our monitoring capability in Defender for Cloud workload protection can offer to you. Then we will show you a real life example of how Defender for Cloud innovation in anti-malware storage scanning can be integrated in organization, operational process, which will allow SOC analysts to better monitor and respond to threats in real time. So in Defender for Cloud, you have this initial overview page where if you scroll down a little bit, you're going to see the workload protections, which is this main tile that gives you some statistics about the alert severity and the timeline of the recent events. Now, if you want to go a little bit deeper, you can go straight to workload protections. The advantage of this page is really to look into your current workloads and how they are covered across the different Defender for Cloud plans. For example, storage, servers, DNS, app services. So you can see everything in one single pane of glass right here. Now, when you go down below, you have the secure alerts, which is a visualization very similar to the overview page. And if you click on the secure alerts, then you're going to see all the details about the alert itself. Now, one thing that is very challenging for SOC teams is to triage alerts, because there are lots of alerts and causes the alert fatigue. So correlation of alerts is very important, because when you correlate the alerts, you know at least which alerts are part of the same attack campaign. For example, usually a threat actor will not just do one malicious operation, they will do multiple operations, and those operations may create more than one alert. So you want to have that correlation, and for that you can create a filter here, okay, for alert name, and you're gonna search for secure incident. The secure incident capability in Defender for Cloud leverages our fusion capability, which is the option that runs behind the scenes, the feature that runs behind the scenes to correlate alerts. So now when I click on this incident and click in view full details, it gives me exactly which alerts are part of this incident. And this is really the powerful thing that's going to save a lot of time when you are investigating, because now you know that there are 3 alerts that are somehow correlated. So instead of chasing those 3 alerts among hundreds, it's all here. So you can do the work much faster and saving times when you are triaging the alerts. Now let's look at an example of how our innovation in data security and threat protection can be applied to a real-world scenario where a threat actor is trying to upload a malicious file into our storage account. So in this situation here, I am posing as the client that is going to upload a file, just a regular PDF file to the storage account. Is the busiest time for the year for controls of finance, is the tax return season, and the goal is to scan every file that gets uploaded to make sure that that file is not malicious. And keep in mind, sometimes the user does not even know that the file is compromised. So the file is, the PDF file is a simple PDF file, and from the user perspective, there is nothing malicious in there. So I'm going to tell my name here, Yuri, and please review this file. And I'm going to select the file that I want to upload. So I'm going to submit the request, click OK. Now at this point, what's happening behind the scenes is Defender for Storage is basically looking at this file that gets uploaded and is going to scan the file using our Microsoft anti-malware engine, which runs behind the scenes and fully integrated with this solution. The idea is, now that the file got scanned, and when I go to the secure alert, I should see an alert that tells me that the file got uploaded. So when I click on the alert itself and click on full details, I have the entire spectrum here. Now, one thing that is important to really understand is that the file not only was prevented to be safe in the storage, but it was deleted. So you have the capability to identify, notify you with the secure alert, and automatically delete or move to quarantine. So you have this capability built in the platform. In the alert itself, you also have all the metadata with the details about the file that was compromised. So for example, if you are synchronizing the alerts from Defender for Cloud to Microsoft Sentinel, all this information will get to Sentinel. So this allows the SOC analyst to review into Sentinel with the context of all the data that was streamed from Defender for Cloud. And here you have details about the storage account, the subscription. One thing that is very important for SOC analysts is the entities that were involved on this potential attack. So you have the entities here. The other thing that is important to emphasize is, for the SOC analyst, is the details about the malware itself, the date, the potential cause, which malware it was identified. And to close the circle, within the take action, what we have is a set of suggestions on how to prevent this type of issue to happen in the future. So this is very powerful, because if you think about secure posture management, it's about continuous improvement. So what you are going to do is you're going to incorporate the lessons learned from this incident to continue improve your secure posture. So this is extremely important, not only for SOC analysts that will utilize this to triage alerts, but also for posture management improver over time. So there you go. A simple yet strong use case to illustrate how anti-malware scanning in the file upload workload that can potentially save the customer cloud's environment from being compromised by a malware. Before we end the session, I want to share some last thoughts on what we have been hearing from customers. Digital transformation is only accelerating in the world of uncertainty. In working with CISOs, a constant theme we have been hearing is the pain of having to spend extra money and time in managing multiple vendors. As you can see from our session today, here in Microsoft, we believe the best CNAPP is the best integrated one. This means integration of DevOps pipeline, integrations of data sensitivity for prioritization, and integrations of multi-cloud threat response. So if you are interested, don't forget to sign up for a free trial of Defender for Cloud and check out our innovations in Defender CSPM, Defender for DevOps, and Defender for Storage. Thank you very much.